Good morning, everybody. My name is Jaime Ramos. I'm professor of electrical engineering here at UTPA. I'm also chair of the Power and Energy Society, Rio Grande Valley, of the Institute of Electrical and Electronic Engineers. That is a professional society. So this presentation is going to have three stages. First, we are going to look at the output power from the arrays which are located out there. Second, we are going to look at the data from another facility. We have a solar station here at the university which assess the amount of solar radiation coming into. So that'll be the second display that we can see here. And finally, third, we're going to walk over to the arrays out there. So let me start with the output from those arrays. So, okay, so that's the website of Meridian company who constructed those arrays. Those arrays were funded by TXU Energy, which is the utility who provides the electricity to the university. So we can see here, okay, so let me go weekly. This is the amount of kilowatt hours produced by those arrays. So we can look at, well, the last one on the right is the current amount of energy flowing in today. So that's incomplete because the day is not over. That's the last one on the right. Then coming to the left column is over 25 kilowatt hours for yesterday and day before yesterday. So those are kilowatt hours produced every day. We can also look at peak power. Oops. What did I do wrong here right now? Detail. I hit the wrong, okay. Here am I. So I want to look at power now. Power here. So that's today's power, okay. So then we can go look at power weekly. So that's the power is being generated by those two arrays, starting today on the right and going backwards on the left. So those are peaked around 4.5 kilowatt. The array capacity is around 5.5 kilowatt DC, because the array produces DC. However, these measurements are AC because the power from those arrays is coming into this building and is being used by the lighting systems. Okay, so that's the performance of this array. Now, we can also look at a station, a solar station that UTPA has installed here on campus, and that is a part of the NREL. So NREL means National Renewable Energy Laboratory. It's a national lab located in Golden, Colorado. So we have a station over here, University of Texas Pan American. So we are part of that network. So we can look at, this is live data, solar, directly solar. So we can look at three components of radiation: global, direct, and diffuse, horizontal. Okay, so those are the three components of solar radiation that we get, and units are watt per square meter. So over there, you can read the actual numbers being produced now. So now I'm going to bring in the graph, submit. And we can see there are 3 curves, 3 colors for global horizontal, direct, and diffuse. And so the peak over there is between 800 and 900 watt per square meter. So that instrument was quite an achievement for us, because from it we can actually evaluate the efficiency of the arrays, several arrays that we have on campus, because those graphs are looking directly into the solar energy received here on campus. Okay, so if you have any question now, please come forward, and then we will walk to the arrays. Okay, so this is looking only at visible radiation. Okay, so the solar flare, I think it brings in a lot of particles, right? Charged particles, high energy particles. So those are not detected by these meters. Okay.
And this readout is from meters, not from power production, not from the panels.
No, this is solar.
Okay, so there's a light meter out there that's
right. Yeah.
Does it allow you to cross to see the efficiency of your system?
Well, yeah, because this will tell us how much energy we are getting from sun, on light, as you said. And then we relate it to the output of the arrays that we have on campus, which are electrical power. And then we can do efficiency measurements on the arrays. So that array, we have calculated it once, and it came around 14% efficiency, 14%. Now, those arrays are tracking. So something which is particularly important to these 2 arrays, they track the sun with 2 axes. So they move and they follow the sun. So during the morning at sunrise, they will look east, and at the end of day, sunset, they look at west. So they have this system for 2 axis tracking. So then we are able to compare the output from that array to another array which is located on the rooftop of the engineering building. That is fixed on the engineering building at the rooftop. So they are same size, 24 modules. However, this one, because being tracking, produces around 25% more energy than the fixed one. Okay, it has 2 motors. Yeah, they are less than half watt each motor, half horsepower. Sorry, they are electric motors, DC motors, step motors.
What makes them follow the
a photo cell on the top of the arrays. So that photocell is looking at the sun and sending signal to the electric motors. It has 2 electric motors. One motor will do the azimuthal motion, and the other motor will do the altitude motion. So there are 2 flat arrays. Each of them has 12 panels. Panels are rated around 240 watts. So 240 times 12 times 2 will give us around 5,500 watts, which is the capacity of the panels. So then the DC power So there are 2 feeders from each array, which are going all the way to the substation yard, which is behind the parabolic dish there. So that's where, that's the site of the main transformer, which feeds the ITT building. So the inverters are there, 2 inverters, 1 for each array. And then the inverters are tied to the 480 3-phase service to the building. So then all the power from these panels are going into the building. The main objective of these arrays is not so much to produce power, but to have facilities as an academic facilities for students so that they can do here projects. All right, so there have been already several senior design projects which the students do at the end of when they are seniors. Okay, then, well, you are welcome to walk in. There are 2 motors, and, well.
Did you say it's 240 watts per panel?
Yes, right, 240 watt.
What does that typically run, 240 watts? What would that run?
Well, remember the typical familiar incandescent light, which is 60 watt. Okay, so 240 we feed 4 of those.
And you use these for lighting inside your building? Is that what you said?
Yeah,
For the lighting?
right.
We have a question over here, Dr. Phillips.
How does the payback compare on the multi-axis tracking versus just installing a flat static panel?
Well, it gives us 20% more energy,
How much did it cost? What was the premium?
around 7 to 5. Okay, so I don't have the numbers. This cost 60,000 and the fixed cost 40,000.
For the same amount of,
Right.
so it doesn't pay back as quickly, but you get more energy overall?
Right. However, our main objective is to have facilities for academic, for teaching, right?
How maintenance intensive, Dr. Ramos, are they?
Well, we need to oil the mechanisms about every 6 months. And with respect to the dust accumulating on the panels, well, yeah, we need to do that also. We need to keep them clean. Otherwise, they require very little maintenance.
Does it damage them if you hit them with water hose or?
No? Damage?
Yeah, if you get up there and they're hot and you hit them with a water hose, it won't crack them?
No, no, no. We have not had severe storms here. They've been here for 2 years. They were installed in October 2010. Again?
What are they rated for, the wind speed?
I cannot answer that.
Are you able to shut off the power from here to be able to work on the other line, or is there power all the time all the way to the inverter?
We have a connection box here, not a switch,
Not a switch, 'cause it's a
but connection box. So
if you need to shut power, you
yeah,
need that connection.
a qualified technician may be able to shoot it down here.
Since it's DC. Yeah,
So this cost about 60,000?
Yeah, no, 2 of them, okay?
Yeah.
You see the other over there? And also the inverters which are over there, the total cost of project.
Oh, okay. For all this?
Yeah.
60.
Do you chance by leaving it there, or do you take it down and restore it?
These things, they will lay down like this, yeah, flat. So whenever they do not find the sun, or at night, every night, they lay down with their belly up.
A storm coming, a hurricane.
Right when I was leaving, they had
You chance it and leave it out here. You don't
Yeah.
hired a professor who was trying to
take it apart and store it in the
I asked him for help to physical plant, right? The message we want to send through is that renewable energy, solar energy, is a working solution now. It's still not very common in society because we must go under a transition from one type of energy to the other. It's going to take time. So the university is fulfilling its purpose of information and education to the students and to the community. They can be, or they can own their own energy producing facilities in residences. Some people here on the Rio Grande Valley already have installed in their own residence photovoltaics. So I'm looking forward to see more of those. I would like to put one in my home now this year.